In the next two sections, we're going to look at the properties and characteristics of liquids and then solids. Now, for both of these states of matter, we're going to revisit two areas. Number one, the kinetic molecular theory and how that applies to both liquids and solids. And then number two, any other properties and characteristics that we can kind of discuss, including things like density and compressibility. So, in both of these cases, kinetic molecular theory and other properties, the big thing that's going to come out of this section is to sort of discuss how these are versus gases, how they compare to gases. Because how gases behave is dramatically different compared to liquids and solids. So as you read through these two sections, you just need to be able to kind of compare and contrast, see the similarities as well as the many differences between gases, liquids, and solids in terms of KMT as well as any other properties and characteristics. Now, to be a little bit more specific in terms of liquids, there are a couple other terms that come in here that weren't in gases. For example, they're going to talk a little bit about surface tension. They're also going to talk about evaporation and boiling. And there is a difference between evaporation and boiling. And then finally, freezing, melting. Right? So those will be a couple of the additional things that are in this section, more specific to liquids. In addition to kinetic molecular theory and some of the other general properties and characteristics for solids, there are also two other properties that we want to talk about. It is basically their shape or their structure, how solids are put together. We'll look at two things. Number one, some solids form crystals. They have a very set crystal structure, a geometric pattern. If you look on page, I believe it's 339, it goes through and kind of goes through the 7 different patterns. You're going to see trigonal, you're going to see cubic, you're going to see hexagonal. Those are the 7 different geometric shapes that crystals form, or the 7 most common patterns. Okay. Now, well, what types of compounds form crystalline solids? There's 4 types of compounds. The first type are ionic. So these are just very simple ionic compounds. We know what those are. Number 2, probably something we're less familiar with, what are called covalent network compounds. These are things like diamonds, quartz, silicon, graphite, so those carbon compounds, and then again the various other quartz, silicon dioxide, things like that. You may have heard of the term buckyballs, Buckminster fullerenes. There's these very big, intricate covalent compounds that are not the discrete little molecules. These are not the covalent ones that would be like M&Ms in your hand. Okay, they're very big, massive, and connected together. Third type of compounds that have crystal structures are metallic compounds. Okay. And then the fourth one are covalent molecular. And these are the things like water, carbon dioxide, ammonia, and so on and so forth. Okay. So, a lot of different structures, a lot of different geometric patterns, 7 of them. And again, we're addressing basically 4 different types of chemical bonds that could form those 7 geometric patterns. The second, last thing that's additional for solids is some solids don't form crystals. They're what we call amorphous solids. Very scientific term here. They're globs. There is no real crystalline or no geometric pattern. They are just randomly arranged molecules. Best example of this is glass, especially older glass. Glass that is very heat resistant is not quite as amorphous because it's able to hold its structure, but older glass is because it can basically just melt and kind of form into this just glob, And again, you don't see it fracture or break into these crystal structures. And that's something we can definitely look at in class. It's kind of neat how that all goes about. So, learned a little bit here about liquids, a little bit about solids. Again, the majority of it you can just kind of read. We'll do a couple things in class to kind of look at some stuff, but some things here you should be able to kind of figure out on your own. So that's it for liquids and solids.